langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, dan good afternoon everyone. Welcome to Pusat Tuisyen Akademi Youtuber with cooperation of EDDEC Malaysia and Guru Malaysia. Okay, I am Mr. Peh. Currently, I am teaching at College Tingkatan 6 to Fatimah Melaka. I am the teacher on duty for this week. And I'm going to continue the subtopic of Chapter 1, which is 1.4, Elasticity. And the lesson will be estimate or expected complete within 1 hour. And you will be take expansion just now. Okay, we will be take about 1 hour to complete the lesson. And the e-certificate or e-sigil link will be provided at the end of the lesson. And please ensure that you complete the form within 30 minutes after the live of lesson finish. Okay, you may also fill up the form with any email you are available. Okay, so for your information, in this week we have actually 2 classes of physics under AYU Pioneer Physics. The class for Form 4 will be presented by Cikgu Linda, and the class for Form 4 class will be held on every Friday, 9:30 p.m. And for Form 5 class will be held on, like today, the Sunday at 8:45 p.m. Okay, so without further ado, so let us start the lesson today's, which is Chapter 1, 1.4 Elasticity. And there are about 4 learning standards you are going to learn for today's lesson. Okay, so for learning standard 1, you need to describe the elasticity. So you need to give the definition for elasticity. Okay, so please define the elasticity. So the elasticity can be defined as a property of a metal that enable an object to return to its original length and shape when the force that act on it is removed. Okay, so you can just observe the figure. So this is a normal spring which is without any load applied on the spring. Okay, so this will be the length and the shape. Okay, so after compressing, you can see the size become shorter. So the length becomes shorter. And then if you stretching the spring, so definitely you can see the spring become longer. And when you bend the spring, the shape will be changes. Okay, so if you release or remove the force applied to the spring, so the spring will be returned to its original length and shape as per the figure labeled as normal here. Okay, so this property we know as elasticity. Okay, so the spring which is in normal condition, you may actually illustrate it as the figure which is consists of molecule. Okay, so you can see here, this is the molecule of the metal or spring here. Okay, so where there is no any external force applied on the spring, where you can see the figure here is labeled as normal. Okay, so the molecule are at their original position, so will be at this position. Okay, so this is the all position of the spring, the molecule of spring, which is at the original position and no any force is applied. Okay, so you can see there will be no any intermolecular forces added within the molecule. So we can mention as there will be no any intermolecular force. Okay, but when you compress the spring, so just like the figure here, okay, when you compress the spring, so the position of the molecule will be changes and they become closer to each other because we bring them become close to each other. Okay, so compressing a solid causes its molecule to be moved closer to each other, as I mentioned just now, right? So you can just look at the figure. Okay, so the distance here becomes shorter. Okay, so what will happen? So the repulsive intermolecular forces act to push the molecule back to their original position. So that means when the two molecules closer to each other, okay, so there will be a repulsion force occur between two molecules here. So why? You can imagine that the molecule consists of the nucleus which is in positive charged. Okay, so they will be have the same charge and repel to each other. Or you can imagine that the outermost of the molecule will be have valence electron. So they will be also have same charges. So when same charges, repulsion force will be occur and they will be try to back to their original position. Okay, so on the other hand, if the spring is stretching, so the distance between two molecules increases. Okay, will be increases. So stretching a solid causes its molecule to be moved further from each other. Okay, so what will happen? So the attractive intermolecular forces act to pull back the molecule to their original position. So when two molecules become further, the attraction will be causes them back to their original position. So which is at the first figure here lah. Okay, so this is happens to the molecule when compression and stretching is applied to the normal spring. Okay. Okay, and then the next here will be the learning standard 2. So here we are going to discuss the experiment to investigate the relationship between the force and the extension of the spring. Okay, as we mentioned just now, when you apply the force to the spring, so you can compress or stretching the spring. So if you stretching the spring, so definitely the length will be increases. Okay, so the length after stretching minus the length of normal spring, so they will be known as extension. So this will be also same for compression. So if you apply the force to the normal spring, so the spring will become shorter. So a different length between the normal and compressed spring will be also known as extension. Okay. Okay, so here, thank you, Cikgu Hasnitah, for follow my lesson. Okay, so the next will be the experiment. You can see this is actually the compulsory experiment for your chapter 1. Okay, so you can get the detail at page number 25 to 26. So basically, the aim of the experiment is to determine the relationship between the force and the extension. Therefore, the manipulated variable here is actually the force. So how you do that? You can just imagine the figure 1.32. Okay, so here, when you put one of the load, for example, 50 gram load to the pin here, so definitely you can see the spring will be stretching, and then we want to get the extension by using the formula here, where S equal to L minus L naught. So L naught will be the length of the spring when there is no any load is applied or put in the bin. Okay? And you minus the load you put on. Okay, you measure the length of the spring with the respective load you put on to the pin. For example, 50 grams. So you see the different length will be known as S, which is extension here. Therefore, the responding will be the length we want to measure. They will be the extension of the spring. Okay, so we'll be responding, and the constant here we're using the same spring. So the stiffness of the spring will be the same. So the stiffness can be referring to the elasticity. Okay, so if the spring is stiffer, the spring will be less elastic. That means it will be more difficult to stretch or compress. Okay, for stiffer spring. Okay, so basically the conclusion of the experiment will be the extension will be directly proportional to the force applied. So that means when you put more load to the spring, definitely the extension will be increases lah. So this is what the expected observation suppose we get. Okay, so the gradients of the graph is actually represented as the 1 over k. So what is a 1 over k? So later on we'll discuss detail about the Hawk's law. So where the formula is actually F equal to Ks. So the F will be force applied, X will be extension. So the K will be the spring constant. Okay, so basically, you can see the formula when we arrange the formula. The K will be F against X. So that means if I say we plot, Okay, so if we plot the graph F against X, the gradients of the graph will be represented as K, which is the spring constant. Okay, and then for the graph we plot here will be S against F. So the gradients here is actually 1 over K. So it will be 1 over spring constant. Okay. Okay, so the spring is obey Hawk's law because the graph is a straight line passing through origin. Okay, so this is two conclusions you get from this experiment. Okay, so you can see that this is a straight line. You get, suppose you have to get, okay, when there is not a straight line or bending line. So that means the spring is not obey the Hawk's law anymore. This one will be discussed at Learning Standard 3 later on. But here I just want to let you know one example question of paper 3, which is related to this experiment. Okay, so this will be the question. Okay, so we straight away discuss one of the questions which is related to paper 3 for this experiment. Okay, so and let's say you already go through many different type of question, so you may know that the paper 3 actually we have two type of amali tugasan here. So one is tugasan amali berbantu, another one will be tidak berbantu. You may also go through more example in my channel. Okay, so you can get more idea regarding the way how you answering the paper 3. Okay, so for this question will be related to tugasan amali berbantu. So that means, okay, so basically you should know already the paper 3 question total marks will be 15 per 115, 155 for paper 1, paper 2, and paper 3. Okay, so firstly, what you have to do. So this is the instruction for the question. So you are not allowed to work with the apparatus in the first 5 minutes. The period is used to check the apparatus list, read the question, and plan the experiment, which is carried out. So mark the box provided to check the material and apparatus prepared and supply. So here we have the list of the apparatus. So you can see here we have different mass of the weight, 50 gram, 100 gram, 150 until 250. So normally we will have or need to get 5 manipulated variable. As mentioned just now, the manipulated variable for this experiment will be the weight or the force. Okay, then you will provided 1 pin, meter rule, spring, rattle stand, and clamp. Okay, so if you check, okay, so you have to check within the 5 minutes, which is advised in the instruction, and then you have to straight away plan your experiment. So for example, here you check already, all the apparatus is available and functioning, you just give a tick. Then immediately you go to read your question and plan what is the MV/RV you need to take and the arrangement of the apparatus also. Okay, so the question I want to discuss will be like this. You are required to conduct an experiment to determine the spring constant. Okay, so just now I explained to you already, the spring constant will be have the unit of K, right? So they will be have 2 type of graph are able to plot for this question. Okay, so just now I also tell you some of the basic knowledge regarding the Hawk's law, which is the F equal to Kx. Okay, Hawk's law. Okay, so the K will be represented as a spring constant, and you want to get the value through this sample question of paper 3. Okay, so here you may plot the graph F against X. And if you rearrange the formula of the Hawk's law, F equal to Kx, you may get that the K will be equal to F over X. So here the gradients of the graph here will be represented as K. Just now I also give you some idea already, right? Okay, so here will be the one of the graph you can imagine the question might be asked during the paper 3 exam. Okay, so and then the another one will be extension against F, which is actually exactly same as what the experiment conducted in your textbook just now. We explained already. Okay, so the gradients here is actually represent as 1 over K. So that means the spring constant. Okay, so that means the spring constant you may get through these 2 different diagrams. The first one will be F against X, and the gradients represent as spring constant. Another one will be X against F, and the gradients will be represent as 1 over K. So that means you need to get your K by using formula 1 divide your gradients lah. Okay, so I just give you the idea. So what is the type of graph might be asked for compulsory experiment in your chapter 1? Okay, so the question will be like this. As per mentioned just now, today we are going to discuss the tugasan amali berbantu. So that means the procedure is provided. Okay, so the procedure will be like this. So carry out the experiment by using the step below. So arrange your apparatus as shown in figure 1. You can see this one. It will be the figure you need to arrange and to get the data. Okay, so mark the initial position of the pin when no load is suspended. So you can see you need to measure the length. Okay, so the length of the spring, initial spring with the symbol L0. Okay, and then hang a 50-gram sorted weight. So you will be the first MV here. Or your first MV will be this on the spring and record the reading. So that means you want to measure again the spring, the length of the spring when the first MV, which is 50 gram of the sorted weight, is put on the spring. Okay, and then you need to find the extension X by formula L1 minus L0. After that, you need to get your others MV2 until MV5 lah. So which is actually already provided in the apparatus list. Okay, so first step, actually you need to identify the MV and RV. Definitely you can actually get from the question or the procedure. Okay, so here is actually you can get from the procedure lah. Okay, so you can see here the sorted weight is actually from 50 to 250 gram. So this will be your MV, and the RV definitely is length you are actually want to measure. So will be extension of the spring. Okay, so the experiment, as per mentioned just now, that might be have two type of graph you will get. So if I say extension against F, so definitely this will be RV against MV, which is normal for most of the experiment. Okay, if I say the question asking you to get the F against X, so it's actually here will be MV against RV, right? So that means this is possible for your y-axis draw for reading of responding variable, okay, for this compulsory experiment. Okay, so here second, okay, so you get already your first MV and RV, you already know your MV and RV, so here you need to know your first MV, definitely here will be 50 gram, and then the RV will be your first extension. Okay, and then the next will be you need to actually recording your all 5 MV and RV. So you need to draft the table where the data you want to get through this experiment. So definitely here will be the F and the L. Actually, you will get L1 first lah. Then L2, L3. Then the X will be using this formula to get. Okay, this will be another MV just now I mentioned to you already lah. Okay, and then you need to draw the table as I mentioned here. Okay, so basically you are advised to complete your experiment about 20 minutes because total time provided for whole paper is about 45 minutes minus the time for reading the instruction, and I ask you to check the apparatus and material and then straight away plan. So this will be actually within 5 minutes. Then 20 minutes to conducting the experiment. You left another 20 minutes to answer your question actually. And the marker will be only mark your question and not how you're doing the experiment. Okay, so here, firstly, you need to know the smallest division or the sensitivity of the apparatus because this is related to the table of the reading you want to plot. Okay. Okay, so here first reading, definitely you need to measure the length of the spring. So you can see from here. Okay, so started is from actually 4. With 4, and then here will be 19. Okay, so 19 minus 4, the length is actually 15. Okay, so that means the initial length of the spring will be 15.0 here. Okay, and then the next will be you need to the hook here provided is actually the first 50 gram lah. Okay, so and we get the reading is about 20. This is just a reference reading for the experiment. Okay, you minus the initial point here will be 4. So the first length is actually 16.0. So why you need to give 0.0? Because the sensitivity of the meter rule will be in 1 decimal place. So you need to give the reading according to the sensitivity of the apparatus. Okay. Okay, so for 100 gram, actually I get 17.1. And then others, here will be reading number 3 with the N 150 gram, I get 18.1. And the 200 gram here, I get 19.1. And the last here will be 250, I get 20.2 cm here. Okay, so this is roughly the reference answer for the experiment I actually did previously. Okay, and then here we straight away go to our question. So just now I mentioned to you already, the experiment, the marker is actually to know how you get the reading. The most important is you need to have the time to answer your question. Okay, your experiment do perfectly without the answer will be also 0 mark. Okay, so the first question here, okay, so this is actually a quite simple question for paper 3 for this experiment. Okay, so the first question asking you about the manipulated variable. So here will be definitely will be the weight of the sorted weight, right? Okay, so here, just like I mentioned to you already, here we have 5 reading 50 to 250 grams. So, and this will be the manipulated variable. So here we measure the sorted weight. And then the responding is what you want to measure or observe here. So definitely there will be the extension. So extension of the spring. So I think this will be very easy and actually is exactly same with the answer where you can get from textbook. Okay, and then the next question here will be tabulation. Okay, so the tabulation here, we need to follow what the question needs for our table. So here, for each different weight, so here symbol is given already as M. We need to follow the symbol given by the question. You cannot simply change the symbol with the respective parameter given by question. Okay, so and then we need to calculate the F and then the extension by using the formula X minus L1 minus L0. Okay, so here the tabulation here must be including the N, F, L0, and L1 and X. So basically, the L0 just now we get already. So will be 15.0 cm here. Okay, so basically this will be the table and the data suppose you know already. So here will be gram, 50 gram, you need to change to force with the unit of Newton. Okay, so here I assume that the 1 kg will be 10 Newton. Okay. Okay, so here first mark, okay, so you can see the marks here will be 6 points. Okay, so here we have, you want to get the 6 mark, the firstly you need to have symbol. So the symbol is given already by the question, you see M, F, L0, L1, and X. So here all the value asked by the question you need to give in your table. Okay, and then the second mark will be correct unit for each parameter. Okay, so it will be gram, Newton, cm for all the length parameter. Then the third mark given will be for your primary reading plus your sensitivity of apparatus and consistency. Okay, so just now I mentioned to you already. So actually the gram is provided by the question. So the decimal place you need to follow the question, which is 50, and no any decimal place if I say you go through the question just now I show you. Then the sensitivity for the Newton, here you can put 0.1. You can put 0.5. You can see all is consistency with 1 decimal place. Okay, and then the length we measure by the ruler. So definitely will be 1 decimal place. As I mentioned to you, the meter rule sensitivity will be 0.1. So you need to have primary reading with correct sensitivity and consistency. So you can see all is with same decimal place. Okay, so how we get 0.5 here I show already. Okay, 50 gram, you change to kg times 10. So you get 0.5 Newton. Okay. Okay, so this can be considered as a secondary reading also. So secondary reading, okay, so here I discuss all the reading first. So you can see the consistency will be always with 1 decimal place. So if I say your first reading 0.5, second reading become 1, you not put 1.0. So that means this will be considered as not consistent because the decimal place is different between the first and second reading. Okay, and then here, okay, this one I mentioned to you already, why I give 1 decimal place because of the sensitivity of meter rule. Okay, so again, you need to give consistent decimal place for your each reading so that you can get your third and fourth mark here. Okay. And then, okay, so 15 cm will be wrong because the sensitivity of the apparatus is not met. Okay, so this is how I given 1 decimal place because of the length of the spring lah. Okay, so here is the first reading, 20.0 minus 4.0. So again, I give 1 decimal place because of the sensitivity of meter rule. Okay, so this will be others, what I get the reading just now, I show you, right? Okay, so again, we need to have the sensitivity, follow the sensitivity of the apparatus and together with the consistency. That means the same decimal place for each reading. Okay, and then the 5 and 6 mark here will be consistency decimal place for your secondary reading. Okay, so here, after minus with the formula provided, okay, which is 16.0 minus 15.0, I get 1.0. So that means here I give my secondary reading with 1 decimal place, which is actually following the sensitivity of the apparatus. Okay, the secondary reading will be the reading where you get by calculation. Okay, so after minus all, I get this reading. Okay, again, need to have the consistency lah. So if let's say you get all the point here correctly, so you'll be get full marks for this question. Okay, so this is the tips how we answering the tabulation for paper 3 regarding this experiment. Okay, then the next will be graph. Okay, so the graph here, just now I mentioned to you, there will be possibility to ask you to plot 2 type of graph for this experiment, x against f and f against x. So the k or the spring constant will be different for the calculation of gradients. So for f against x, the gradients will be represented as k. For x against f, the gradients will be 1 over k. Okay, so here will be the reading I get from the table just now. So where the question asking us to plot f against x. So the y-axis will be f, the x-axis will be x. Okay, so this will be the graph provided. So firstly, you need to give a symbol. So here the marks will be 3 marks. So how you get the 3 marks? You need to have correct all the 7 ticks here. So first will be the symbol. Here, question given us already f and x. Second, you need to give the correct unit. Then third, you need to give the correct skill. So where all the reading minimum and maximum must be included in your skill, and then your reading must be started with 0, and your skill must be multiple 1, 2, 5, and 10. Okay, so here you will be the example of correct skill I advise here. So you can see the force here will be maximum reading 2.5 is cover. Maximum here is 2.0 already. Minimum 0.5 is also included. And then the x maximum value 5.2. You can see my skill is more than 5.2, which is 6 here. And then the minimum reading definitely is covering the 1.0 here already. Okay, so the size of the graph must be 4 times 5. What is 4 times 5? 4 will be 4 unit. So 10 box will be represented as 1 unit. And then 5 unit will be here. So in simply way said that the graph must be more than half the size of the graph. Okay, and then for more easier for calculation, you need to know the smallest division. For x, axis will be 1 divide 10 box will be 0.1. Then the y-axis will be 0.5 divide 10, I get 0.05 for one smaller box. Okay, so then you need to plot all the point correctly. So you will get tick number 5, number 6. Okay, so here will be our first reading. The f here, you can using 0.5 divide 0.05. Then you know how many box you will get. So here will be 10. Okay, and then also for y, also for x reading here. So this will be our first point. Then second point will be 1 for f, 2.1 for s axis. Okay, and then others also. So if I say you can able to plot all the point correctly, you'll get tick number 5 and number 6. Okay, so why is the tick number 7 here? So tick number 7 will be the baseline. Okay, so what is the baseline here? So here we have 2 criteria to meet the baseline. So the point above and below the line cannot be more than 1. So what is it means by this? Let I show you. And then the point must have a distance less than 0.5 cm. Okay, so for example, this is my graph. You can see all the point. Okay, so here is on the line, this is on the line, and this also on the line. Only the second point is below the line. There will be 0 point upper the line. So 1 minus 0, I get 1. So the different point upper and lower the line less than 1. So here consider is a baseline. And then second, you can see the distance of the point to the line. So for example, here, the distance will be here to the line, cannot more than 0.5 cm. If I say you can meet these 2 requirements, so this considered as a baseline. Okay, so if you manage to get this 7 tick, you'll get full mark or 3 mark for this question. Okay, then the next question will be, the question asks you the relationship between f and x. So definitely you can see here is a straight line passing through the origin. So this will be the directly proportional, right? Where you learned already at chapter 1 from 4. So here will be s is directly proportional to x. Then you get 1 mark. It's very easy. Okay. Okay, then the E will be the gradients. Okay, so as you read already the question actually asks you to determine the spring constant for the spring. So for graph f against x, so the spring constant able to get by calculate the gradients. So first mark, okay, so here we have 3 marks. So the first mark you need to draw right angle triangle. And then we need to get bigger one, big enough. Okay, so normally it will be 4 times 4. So here will be the line, and then you need to draw the right angle. This will be the first mark. Okay, and then gradients, definitely you need to get 2 points here. Okay, so here will be a 0.1, 0.00 origin. Second point will be 5.2, 2.5. Okay, using the formula y equal to y1, sorry, m will be gradients are simple, minus y2, x1 minus x2. So you may get the answer. So show the step for second mark, and then correct unit with minimum 2 decimal places. So you will get third marks. Okay, so make sure your unit is correct. Okay, so here you can just get from axis y, which is Newton, and then the x here will be cm. So you'll get Newton per meter. Okay, so if I say you got any question, you can just type in the chat room so that I can discuss with you here. Okay, so here we have already finished our learning standard 2. So I think we can go for break before we continue our lesson for learning standard 3. Hi, welcome back. Okay, so for information, you can actually get the worksheet for today's lesson through the link provided here. And the link is actually, you may also get through the description in the video below. Okay. Okay, so let us continue our learning standard 3. Okay, so communicate about the law related to force and extension of spring X. Okay, so actually just now I also give you the idea already. So the one and only law related to this subtopic 1.4 elasticity, there will be Ohm's law. Okay, so what is actually the Ohm's law? Okay, just now I show you the formula F equal to KX. So you can actually straight away define the law through the graph. Okay, so here actually, if I say you already go through the experiment 1.1 at your textbook, okay, so you can see the graph actually want to plot is X against F, because X is RV, where we measure, and then the F will be the NV. Okay, so where the weight you actually will be hang on the spring for the experiment. Okay, so here will be the graph X against F. So the definition will be X, which is the extension of the spring, will be directly proportional to the force applied. Okay, so here you need to add on, as long as the elastic limit is not existed. Okay, so here you can see if the graph you get is a straight line, so that means this is obey the Ohm's law. Okay, when you put more and more load on the spring, definitely your spring will be broken and not able to go back to original length or shape already. So then you will get a curved line. Okay, so when the graph you get start to showing the curved line, so the point here we know as the elastic limit. Okay, so this is a straight line. Okay, and then here, okay, so this is the formula just now I show you, F equal to Kx. So the F will be the force on the spring, and then the X will be extension of spring, and then the K will be spring constant. Just now we already discussed the detail of experiment at learning center 2, right? Okay, so this is the formula you need to remember. Okay, and then the elastic limit, just now I show you, will be this point, right? So where the graph start to showing curve. Okay, so here will be the definition for elastic limit. So is the maximum weight that can be applied to the spring such that the spring will be able to return to its original length when the force is removed. Okay, so from first slide I showed you already. So you can bend, you can stretch, compress your spring, right? Okay, so the shape will change when you remove all the force. If the spring able to back to the original position, so that means it still not exist the elastic limit. Okay, will be this point. Okay, so after this point, so the spring consider is broken already and not able to obey the Ohm's law anymore. Okay, so if a spring stretches, if the force stretches the spring over its elastic limit, so the spring cannot return to its original length even though the force no longer acts on it. Okay, so that means the Hooke's law is not obeyed anymore. Okay, so here will be the graph F against extension. Actually, just now I also discussed with you through the experiment already. Okay, so here will be the importance point. So the first will be, here you can see the straight line passing through origin for the graph F against X. So that means the F is directly proportional to X. Will be like the straight line showing here. Then second, the gradients, which is N, which actually will be the spring constant. This one, just now I also show you at the hot tips in the experiment in learning standard 2. Okay, so the M here will be represented as K. Okay, then the next, okay, so here will be area under the graph. You can see here we have green color triangle. So what is the meanings by this? Okay, so it's actually the work done to extend the spring. We're using symbol W here, which is equal to elastic potential energy. So that means the elastic potential energy can be get by calculate the area under the ground. Okay, will be represent as A here. Okay, so here work done elastic W will be equal to potential energy. You can see here. So both of these able to get through the area under the ground. Okay, so here will be the formula related. So the work done W will be 1/2 Fx, and potential energy 1/2 kx squared. So the F will be the force applied, X will be extension, and the K here will be the spring constant. Okay, so here will be the calculation parts where will be you may see in the most problem solving in subtopic of 1.4 here. Okay, so here the spring constant. Okay, just now I showed you already. The spring constant will be the gradients for the graph F against X. You can see here. The spring constant with unit of K, symbol of K or spring is the force required to produce 1 unit of extension of the spring F. Okay, so this is the definition of spring constant. You can memorize, okay, by formula. You see, come from F equal to Kx, and you rearrange, you get that the formula will be F against X. So you can see here, F will be spring, is the force, okay, the force required to produce 1 unit of extension. So the extension will be X. Okay, you just memorize by this formula lah. And then the unit here, unit SI for force will be Newton, length will be meter. So you get the unit will be Newton per meter. Then the K, okay, so what is the meanings of K here? So the K is actually measuring the stiffness and elasticity of the spring. Okay, so here you can see we have 2 graphs. So the F against X, so that means the gradients represent as K. So the greater M will be have greater K, right? So you can see here the gradients for this triangle is actually bigger compared to this. So here you can see the length with greater M labeled as stiff spring. So that means this is the more harder spring. So that means the elasticity is lesser. Okay, so here will be the conclusion. So the spring with high spring constant will be this. Is harder to extend and is said to be more stiff or less elastic. Okay, so that means the extension will be smaller for same loading given for stiff spring and soft spring here. Okay, then for the, okay, you can see here, just I already explained to you. So here, the stiff spring have greater M, so will be stiffer. Okay, so there will be vice versa for the graph X against F. So for this, the stiffer spring will be has smaller gradients because the gradients for X against F will be 1/K. Okay, I actually repeat many times already. Okay, hopefully you may able to differentiate the graph between X against F and the F against X. Okay, so here the point number 4, a spring with small spring constant K, okay, will be this, is easier to extend and is say less stiff, is soft actually, less stiff is actually soft and more elastic. Okay, so this will be the information, main point for spring constant. Okay, you need to take note here. Okay, then we go to the factor that affects the elasticity. Okay, so here the first factor, actually we have about 4 factors. So here the first factor will be the length. So here we compare the spring P and Q. Okay, so after the experiment, okay, so you can get this again, F again X. The gradients will be spring constant. So that means greater gradients will be given greater spring constant. They will be harder. So that means here spring P is actually stiffer compared to Q and less elastic. Okay, you can just compare the gradients again. Okay, so here P will be stronger actually. Okay, conclusion, a shorter spring is stiffer or less elastic. Okay, so the second factor here will be diameter or spring wire. Okay, so here we compare the thickness of wire. So the diameter is the same. So here diameter, same, just a spring. Wire is different, the thickness. So P is thicker, Q is thinner. Definitely the thicker wire will be stronger. So we expected the gradients for spring P is higher. Okay, it's higher. Okay, so here conclusion, a spring with thicker wire is stiffer. Okay, then the next will be the diameter. Okay, so you can see here the wire size, the wire thickness is the same, but diameter here is different. So diameter here is bigger, this is smaller. Okay, so which will be stronger? So here, after the experiment, you can see spring Q is actually stronger with a smaller diameter. So that means the extension for Q will be smaller with the same weight is applied to the both spring here. Okay, here again we compare the gradients. Okay, conclusion, a spring with smaller diameter of coin is stiffer. That means will be less elastic. And then the last factor here will be type of material. So here we do a comparison between the steel and copper. The steel is actually the alloy. Definitely alloy will be harder compared to the pure metal. Okay, so expected the P spring is stronger because of the greater gradients here. Okay, so here conclusion. Okay, so a steel wire is stiffer or less elastic compared to copper wire. Okay, spring made with different type of material had different stiffness and elasticity. So this will be the point, the fourth factor affecting the elasticity. Okay, so here will be the question actually I take from textbook, question number 2, page 32. Okay, so here will be the calculation. So this is a question. So figure show the graph of force against extension for a spring. So stack the Hawk's law. Again, this one you just need to using the graph X against F. They will be directly proportional with the requirement where the spring is not exist the elastic limit. Right? So you can see answer, extension of the spring is directly proportional to force applied. So here will be F. Here will be X. As long as not existing the elastic limit. This will be the condition. Okay, then does the spring obey Hawk's law? So I said the graph showing straight line passing through origin. Definitely this will be obey the Hawk's law. You can see this is a straight line, right? So the spring is obey the Hawk's law. Reason because the graph is straight line passing through origin. Okay, here the next will be the calculation. Okay, so here spring constant for graph F against X will be showing by gradients, where the gradients will be given K, right? I show you so many times already. Okay, so here F equal to KX. So when graph given here with F against X, so the gradients represent the K. So you just using the X value 15, divide Y value here. So you can get 250 Newton per meter. Okay. Then the next here will be what is the elastic potential energy in the spring when stretched to an extension here. You see, elastic potential energy. Just now we have two formula, right? So here will be you need to calculate area under the graph. So be here, 2.4 is here. So we need to find the area for this triangle. Okay, so 1 over 2, base 0.4 will be here. Then the height here will be 10. So press calculator, you get 0.02 joule. Okay, then the next here will be the question number 3. Okay, so again, this is a related question from practice 1.4. You can actually get from textbook, page 32. Okay, so the question will be like this. Okay, so the figure shows the graph f against x and shaded region given as 0.4. So here we have two information can get through the graph. Gradients showing the spring constant, and then area under the graph will be the energy, elasticity of energy for the spring. Okay, so what is the force that produce the extension 5 cm? So you can see here 5. So question want to get the value of F. So X is actually 5 cm. Okay, so we want to get the value of F. Okay, so this will be related to the formula we learned just now. Okay, here will be two formula, 1 over 2 Fx, 1 over 2 Kx squared. Okay, so F is, we want to find the value. X is provided. So that means we're using this formula. Okay, and this formula is equivalent to the area under the graph, which is given by the question, 0.4 here. Okay, so we're using this formula. Area under the graph will be 1 over 2 Fx. Okay, so 0.4 given by the question already here. 0.05. Why? Because here we want to change cm to SI unit. Okay, becomes 0.05 meter. So press calculator, you get your value. The force here will be 16 Newton. Make sure you keep the correct unit. Okay, then B, spring constant, as per mentioned just now, they will be the gradients of the graph F against X. So here you have two ways to get. Straight away you can get from formula also lah. Okay, E is given at 0.4 also. Then we can get K with the extension given, which is 0.05. Okay, we arrange to get 322 Newton per meter, or you can straight away calculate gradients. So where here we get 16 from A, here will be 0.05 meter. So end up, you can get the same answer. Okay, so this will be the reference discussion for question 4, practice 1.4. You may see at textbook 1. Okay, then we go to the last learning standard. Okay, we still have one more learning standard. Here will be the problem solving involving the force and extension spring. So again, here will be the calculation. Okay, so here you need to understand the arrangement of identical spring. So identical spring, that means they have the same spring constant here, okay? Same length. Okay, so here the spring can be arranged in series, so you'll be like this figure. So the spring will be connected end to end here, okay? And then the parallel spring connection or arrangement will be like this lah. Okay, so both the spring will be share the load provided here. Okay, so here force applied will be same F here. Okay, so here we have 3 important information you need to know. So the tension in each spring, okay, and the numbers of spring here is provided, actually is 2 lah. If I say you're referring to this figure, but in general, if I say we given N, you can apply for all numbers of spring here. The extension, the tension in each spring, that means the force applied to the spring 1 and 2 here. So what is the tension for each spring here? So using formula F lah. So that means here will be F and F. Then for parallel, there will be F over N. So that means here for this case will be N, F over 2 lah, because we have 2 spring. And here will be F over 2. So that means the force applied to respective spring in arrangement of parallel is actually smaller. Definitely, the extension will be smaller lah. Right? So you can see here, extension here F will be, that means it will be X. Then here will be half lah. That means here will be extension S over 2. Here will be S over 2 because both spring actually sharing the load, sharing the force lah. Okay, so total extension here, you can see here we have X and X. They will be 2X or NX lah. N referring to numbers of spring. Okay, and then here will be X over 3 also, S over N also. Okay, so just now I showed already. And here will be X over N, so there will be X over 2 lah. Okay, so you just remember these two point for calculation, so you may get correctly. Okay, so here we go to checkpoint again, calculation. This will be the example question you may get in textbook actually, page 31 to 32. Okay, so here the first question, a spring with the original length 50 mm extend by 6 mm, so that means here will be X. Okay, so stretched by the force. Okay, so the force here is 12 Newton. Calculate the spring constant. Okay, so straight away using formula F equal to KX lah. X provided, F provided, and then you need to find K. So with given value F equal to 12, X equal to 6 mm. With the formula here, rearrange, you get K equal to F over X. You just substitute all the value. Okay, so you get 2 Newton mm per mm lah here, because I not changed to SI unit. So you can maintain 2 unless the question asks you to change to SI unit. Okay, then the B here, okay, so here for 3 arrangement. So here we have 3 arrangement, ABC, you need to identify tension of each spring, extension, total extension, and the total length for arrangement, for the respective arrangement. So we calculate the A first lah, here. Okay, so A, you can see this is arrangement in series lah. Okay, so the extension given as 6 mm per spring, and the F is given as 12 Newton. Okay, so here will be the information just now we discussed already. Okay, so definitely series we follow here lah. Okay, we not see these parts. Okay, so here the first question asking you to find the tension for each spring. So here the force applied is 12. So that means the tension applied for spring P will be F, which is 12. Q also 12. Okay, will be this. Very easy. Then B, the question asking you the extension. You see extension will be X. The X is given as 6 mm. So that means the respective extension for P and Q will be 6 mm lah. Very straightforward. You just follow the tips are given here. Okay, then the next, number 3, total extension. Total extension, we're using formula NX. Right? N here will be 2. We have only 2 spring. X will be 6. So using formula, you get 12 mm. Or you can straight away additional for these 2 value. You get also 12 lah. Or you can straight away apply the formula here. Okay, then the last here, the total length. Okay, so here originally, there will be 50 mm provided by the question. Here also 50. Then after extension, we get 12. So there will be 50, 50 plus 12. So you see, original length for P, 50. Q, 50. Extension, here we get from answer number 3. So we get 112 lah. Right? So it's very easy. Okay, and then the next here will be the arrangement in B. Okay, so here we look at B. Definitely the arrangement here will be parallel. So we don't need to see series anymore. Right? Okay, so here as A, the first question asks you about tension. Here we apply formula F over N. So F given as 12. N here we have 2. So that means 12 over 2 lah. Right? Given 12. So 12 over 2, you get 6 for both spring R and X here. You see, both will be using the same formula, very straightforward. Okay, then the next here will be the extension, we're using formula S over N. So X given as 6 and N will be 2 spring, right? So substitute X over N, 6 over 2, then you get 3 Cn for R and also S, same formula. Then the extension, here we're using same formula S over N. So you get 3 also lah. Okay, so that means here, the total extension will be actually, both will be same length, 50. You just need to take one. Then the extension here is only 3 for both, right? Here also 50 and 3. So total extension, they will be 50 plus 3 actually. You get 53 lah. Okay, so this will be the step 50 plus 13. So you get 53. Okay, and then the next will be the last arrangement. Okay, so here will be mixed between arrangement of parallel and series lah. Right? So the question also given already. Same load with 12 Newton. Extension for each spring will be 6. Okay, so how we do this? Okay, again, we're using these hop tips. Okay, so here, TUV will be arranged in parallel. So using this formula, then the W is a one and only spring arranged in series. So you're using formula here. Okay, TUV arrangement in parallel, W in series lah. Okay, so how we do that? So first tension for first 3 TUV, all be the same, using F over N. F is 12, N here will be 3, TUV, right? We had 3 in arrangement of series, so N will be 3 here. So it will be 12 over 3 lah. So you get 4 Newton for each spring, TU and V. Okay, then for W, you need to follow this rule, which is 12. Okay, so be 12 lah. Then the second extension for TUV, you need to follow this. The X given as 6. And here we have 3 spring TUV. So that means it will be 2. Very straightforward, right? Just apply the formula. Okay, then the extension for W using X, which is 6. So the answer will be 6. Okay, so this will be the step. Okay, the next total extension. Okay, so here you need to think that the original length for TUV all will be together 50 only lah. Extension here will be 2. Extension will be 2. So that means here will be 52. Then here will be 50 plus extension 12. Here will be 6. Here we get 6. Will be 56. Total will be 52 plus 56. 108 will be the answer. Can you see? Or you can using the formula. Here will be the arrangement for parallel. X will be 6. N will be 3. Oh, here will be the extension only. And then here will be parallel, which is 1 and 6. So you get 8 and N. Then the extension for all will be this. I show you already. Here, 50. Here, 50. Here, 8. So we get 108. Okay? Okay, we go to our next question. Question number 3. You may get at page 32 also. Okay, so the question will be like this. Figure show an arrangement consisting 3 identical spring P, Q, R will be this. So this will be compression. Just now one will be stretching. So again, here will be parallel. Here will be series. Okay, we're using this formula again. P will be series. And then QR will be parallel. Okay, again, here the question asks you to find. Okay, so here the question given us spring constant. Okay, and then given us F. Okay, so determine force experienced by each spring. Again, we're using this and this. Okay, so for P will be F, which is 8, right? Given by question here, 8. And then for R and Q, they will be using F over N, and the N here will be 2, 1, 2. So F is 8 divide 2, we get 4, right? So this will be straightforward, you can apply. Okay, and then the B here will be compression of each spring. So compression, there will be extension of spring using this lah. So we compress how much here. So actually we're using this. Extension will be stretching, then compression will become shorter lah. Okay, so here we're using same formula. So for QR, okay, so here we need to find out the extension for one spring first by using this formula, F and K. F is equal to Kx. So we get the extension will be 2 cm. Okay, so because the question not given us the extension for one spring, so here we need to find out first. So where will be 2? Okay, so here only we apply this formula. Okay, so for P, so P is the one and only, which is arranged in series lah. So there will be X, right? So X will be 2. So answer is 2. Very easy. Okay, and then the Q and R using this formula. X we get 2. Here spring we have 2. So we get 1 for each spring here. Okay. So this will be the way how we calculate. Okay, so the compression, so that means we want to get a total value here lah. So here we need to use minus. Initially, the spring is 2. Initially the spring. Okay, so here we have to find the total compression. Actually, the total compression here we can get ready lah. 2 for P, and then 1 for Q and R. So answer is actually 3. Or we can using this formula lah, as I mentioned just now. If let's say you don't know everything, right? Okay, so we're using total compression in parallel will be this. X will be 2, N will be 2 because we have 2 spring. Then here, spring P we have only, so be 2 lah. You can using formula, you get 3 also, or you can straight away get the answer additional 2 and 1 from B. Okay, so this will be the calculation for learning standard 4. Okay, so I still have last question. Okay, so this will be the question from 2013. Okay, so this will be the modification question, paper 2, section A. So will be conclusion for subtopic of today's actually. Okay, last question here. Okay, so the diagram 7 shows a load hang on the spring. Okay, so the load will be here. Spring will be here. Okay, so the first, okay, so here the question given us, the mass of the load can be determined by this formula. This is a Hooke's law. F is actually force, K is actually spring constant, and X is actually extension. Okay, here name the physics law. Very easy. There will be one and only law you learn in this subtopic. There will be Hooke's law. So it's very easy to get 1 mark here, but make sure the spelling is correct. Okay, and then the second will be a calculation, just now we just go through. Okay, so the mass of the load is given as 1. Calculate the spring constant. We want to get K. And then the extension will be X. So all can be changed to symbol. So here we have to get the K with the load given as 1. So that means we want to find the F by using W equal to mg, right? Here, the weight will be W equal to mg. G will be normally using 9.81 if I say not given any value. Okay, so here, again, we're using a formula, K equal to F over X. Then F equal to mg, as I show you here. Substitute M equal to 1, G equal to 9.81. Divide 2. Okay, so you get answer 4.905 Newton per cm. So make sure you answer minimum 2 decimal places with correct answer. So you get 2 marks. Substitution, 1 mark. Answer with minimum 2 decimal places and unit, you get another mark. Okay, so here will be the knowledge you actually learned just now, where the factor affecting the stiffness and elasticity of the spring. Okay, so spring P break when it is used to hang a heavy load. So suggest a modification that can be made to hang a heavier load that through this aspect. Okay, so first, stiffness. So stiffness, definitely we need to increase the stiffness lah. So how we increase the stiffness? So we can using the spring with higher spring constant. So answer here, first mark will be using stiffer spring where the spring constant is higher lah. This one just now we explained already. Okay, and then the second, the thickness of the wire. Okay, so here thickness must be thicker lah. So thicker wire will be have greater spring constant. You can see thicker wire will be used. Reason here will be thicker spring have higher spring constant. Okay, then the next here will be the type of the material. Just now we have a example, copper between steel. We choose the steel because the steel is an alloy. So alloy definitely will be harder lah. Okay, so here actually we using spring, steel spring, okay, because the spring is harder and stiff lah. So this is the answer for this question. And then we go to our last question. Okay, so another identical spring Q is used to hang the heavy load. Suggest a arrangement of this spring to hang the heavy load without breaking the noose. Okay, so here definitely we have 2 options, series and parallel. Definitely we'll choose parallel lah, because the parallel will be sharing the load between 2 spring, okay, and given shorter extension. So the answer here will be one and only answer, which is parallel lah. So it's very straightforward, okay, because the spring arranged in parallel will be given overall larger K, harder and less elastic lah. So this will be the hot tips I want to share to you. Okay, so finally we managed to complete the 4 learning standards in this subtopic. Okay, so that's all actually for my sharing for subtopic 1.4. Okay, so please click like and share link of the lesson today to your friends so that most of your friends able to get benefits from my lesson. Okay, so here I want to share to you the e-link sigil or certificate link. Okay, I share to you at the I share you the link at the chat room. Okay, so I shared to you already the link for e-certificate or e-link sigil in the chat room. Okay, so please fill out completely within 30 minutes after the live or lesson end. Okay, so don't forget to follow our next physics classes, where every Friday will be the physics Form 4 lesson, Okay, 9:30 p.m. So the next presenter will be Cikgu Izyan, and there will be subtopic of 2.2, linear motion graph. And then for the Form 5 class will be on every Sunday. Okay, 9:30 p.m. The next presenter will be Cikgu Hasnitah, our KP, Physics AYU. Okay, so we will enter our new chapter, which is chapter 2. Okay, chapter 2, first subtopic will be pressure in liquid lah. Okay, so thank you everyone who joins my lesson today. Okay, especially my best partner, Cikgu Hasnitah. Thank you for support me until here. Okay, so that's all for my sharing. Okay, see you all again next time. So anything you want to share with me, you may share with me at the chat room. So that's all for my today's sharing. Bye-bye.